A movie recommendation matches your mood with eerie accuracy. A search bar anticipates your question before you finish typing. A map suggests a calculated reroute moments before you encounter a traffic jam. These outcomes are the results of a hidden architecture operating beneath the glass of our screens. This architecture, the algorithm, functions as an invisible filter, determining which emails are flagged as spam, which news reaches your feed, and how your digital world is prioritized. Because these systems operate in the background of almost every decision we make, we have to ask if they are assisting our choices or quietly replacing them. In The Invisible Algorithm, author Ravindra Kumar Nayak explores the tension between these automated rules and our individual agency. Nayak's investigation centers on a specific danger. The most influential systems in our lives are often the ones we are never taught to see. Regaining control requires us to work backward from the results on our devices to understand how these rules are built from first principles. Understanding an algorithm requires looking away from computers and toward the basics of human behavior. Long before the first line of code was written, a farmer would watch the sky. They would notice that dark clouds were followed by rain, or that specific seeds produced the strongest crops. This is the root of learning, identifying a pattern in the physical world. Once a pattern repeats consistently, we formulate a rule to predict what will happen next. If it rains, we take an umbrella. If the soil is dry, we provide water. When we organize these rules into a sequence to solve a larger problem, like a recipe for a meal or a set of directions for a journey, we have created a procedure. This reveals our first principle. An algorithm is a sequence of human instructions, crafted to move from a specific input to a predictable output. This architecture relies on 4 stages. Raw data enters as an input, a rule acts upon it, an output is produced, and feedback allows the system to adjust the rule for the next time. Every algorithm, no matter how complex, began as an automated version of human intuition. The complexity increases when we hand these human instructions to a machine and ask it to execute them millions of times per second. AI systems do not process information through meaning or emotion. They function through numbers and spatial geometry. This taste profile illustrates the translation process. Subjective preferences become numerical values, turning your personality into a coordinate in high-dimensional space. The machine calculates the mathematical distance between your coordinate and points representing thousands of movies. A recommendation is simply a geometrically close point. When plotted together, these data points gather into clusters, revealing shared behaviors invisible to the naked eye. Optimization draws rigid boundaries around these clusters, using them to predict your next action based on your nearest neighbors. If these models are now driving our economy and our social interactions, we have to ask if they are finding truth or merely finding patterns in a vacuum of context. The intimidating scale of AI is ultimately the simple math of measuring distance, performed at an incomprehensible speed. These geometric models are precise, but they are blind to the reality outside of their data. When a system is tuned to maximize a single target, like engagement or speed, it creates a hidden friction with the human needs it ignores. This narrow optimization generates a structural tension that eventually causes the system to fail. While an algorithm can sort data into clusters, it lacks the ability to understand meaning, ethics, or the consequences of its predictions. This creates a dangerous reliance on mathematical accuracy. We often confuse a machine's ability to calculate at scale with actual wisdom, and we mistake its consistency for authority. Deferring responsibility to an optimized system means surrendering our agency to a tool that understands calculation but lacks the capacity for care. When an algorithm uses a child's past mistakes to limit their future path, it is no longer a prediction. It is a mechanism for making that future smaller. To maintain our humanity in an automated world, technology must serve as the assistant to our thinking, rather than the owner of our conscience. Now that we can recognize the invisible rules, the question is whether we will have the courage to override them when they conflict with our values. Algorithms are tools waiting for human judgment. Every screen presents a calculated suggestion, requiring your critical eye to decide what is truly worth following.